Record this video showing how I prepare templates for wplace and bplace. I'll be using bplace as the example for this one. Alright, so I start by finding the minimum and maximum colors that are already in the image. And I use a medium blur for that. On maximum radius, 0 percentile. Maximum quality, this is to find the minimum. We see the minimum is 0. All zeros. And then the maximum, yeah, all 255s. Okay, so no minimum and maximum adjustments. Okay, so next, go into levels. I do ShareX. So I use ShareX's color identification feature in its screenshot tool to tell me what color the average is. 162, 190, 183. So I write that in here. I'm gonna put this here, and I'm gonna put my calculator here because I'm gonna need that later. I will, however, shrink these so that I can make the paint.net window bigger. And let's get rid of the documents list on here also so that I can fit as much in here as possible. Okay. So now what I want to do is adjust the gamma such that the average color becomes, 150, 132, 135, because that's the average color of the bplace palette. For wplace, it's 150, 136, 129. No, oh shit. So I just do trial and error to see what gamma adjustment gives me the correct average color. Oh, didn't mean to do that. So 1.17, and then I cube root it. If I'm doing minimum and maximum adjustment, since that'll usually adjust the average color as well, when I change the maximum and minimum, I'll need to recheck the average on that level, and I adjust the average in that case to what it is at the start. That's why I write the starting average color, this one. That's why I write that down at the start, so that if I need to do minimum and maximum adjustments, I can find the gamma that brings it to that level, and then I multiply the two values that I get together, and then I take the cube root of that. So I'm basically doing the geometric mean of no adjustment, the adjustment to get to the average palette color, and the adjustment to get to the average starting color. So right now, two of those are 1, and the other is 1.17, so I just do the cube root of 1.17. And I get this, so I bring that there. And I do the same for the other channels. Right. Okay, so that's the levels adjustment. And then I resize the image using Fant downscaling. And I basically do trial and error at various levels to find which one preserves the details that I want. In this case, I want Melman's eyes. And I happen to already know that the one that gives me what I want is 88 by 53. So that's that. And then I kind of do the same thing again. Okay, so the maximum for this is 255, 255, 247. Minimum is 084. And then let's also put these two values. And then I also check the average color that it's at right now. So that's 159, 177, 173. And then input maximum 247. 4 and 8. Make sure those are right, because Paint.net likes to mess around with those for some reason. I don't think that's an intended feature, but they haven't responded to my email about it. Okay, so 159 to 162. .97. And I already saw that the average was 159, so I don't need to check for that. That'll already be 1, and then that's another 1 for no adjustment. Okay, so 1.12, and then do the fourth root of that, whatever, tesseractic root or whatever. 102. .177. Here's 190. And it's faster to just do 2 square roots. Just double click the square root button rather than do second and then this and then 4. Because it's the same thing. The square root of a square root is the same as the root base 4, or however you say that. 1.07. Okay, so that rounds closer to 1.06. And doing it this way gives a more subtle adjustment, which is better for, it's less jarring. And of course we're going to be dithering this, so it's not going to be as obvious that we're adjusting it at all, but it does mean that it uses the palette of the thing we're using more effectively. And I always also check the one right above just to make sure we're adjusting it as little as possible, or as little as needed to get the right average. Sometimes multiple gamma values will give you the same average, so I want to use the one closest to 1. Okay. And 1.14. All right, and now save that as um, 88 by 53, 150, 132, 135. Make sure it saves as a PNG. All right, now head to ditherit.com, throw that in there, import palette, and I have, here it is, copy that, paste that in here, set this to Burke's dithering with no serpentine dither. It's slightly higher quality than the standard Floyd-Steinberg since it dithers over a wider area, but it still keeps Floyd-Steinberg's characteristic checkerboard pattern that I like. There's also Sierra 24A, which does a similar thing. I tend to like Burke's because it gives a smaller file size, which, you know, it's not like file size is important, but it suggests that it's probably simpler or something, so, you know, take that. Okay, now we open this up and add the palette that I'm using to this. And what I do is I select every one of these with the magic wand, every single color, to see which colors in the palette are actually used. Okay, and now find what the average color of this is. 159, 154, 128. Make sure that's right. 159, 154, 128. And now we do the same thing again, but targeted to this new average. Get my calculator back. This will usually result in levels that are that are a less extreme adjustment, similarly to the thing we do with cube roots and tesseract roots. I don't think tesseract root is a common term for that. But, I mean, a tesseract is the four-dimensional equivalent of a square and a cube, so that should be what it's called. Okay, and then maximum's the same. 162, 181, 172. Okay, this might actually end up. No, it might. I'm guessing it'll probably still be 1.01. Yeah. Because if that ever ends up being, if that ends up ever rounding to 1.00, I'll have to hit reset because it won't let you move the slider back to exactly 1.00. You can only get that by resetting, and then you'll also have to re-input the minimum and maximum for every channel individually. Did I? Okay, yeah, I did that right. Wanted to make sure I actually did a square root of a square root rather than accidentally doing a cube root. That should be 172. Oh, that was 0.9. I didn't mean to clear it. All right, and now save that as 159, 154. 128. Make sure to click import again so that it actually uses the right palette. And now let's open this one up. And subsequent palette checks will also include the palette we did before. I used to just completely recheck, but when you do that, it tends to get caught in loops and never really settle on any one specific palette. And also it just takes forever. So we basically find colors that are in this image or any previously generated image. In order to find the average color of all of those. And this is not the average color of the generated image. It's the average color of the colors in the image completely independently of how frequently those colors appear. Those might be the same. 159, 154, 128. 159, 154, 128. All right, we're done. Okay, so this is the template then. So I save that as, make sure it saves as a PNG by getting rid of any extra layers. Show me the number I want. I always include the dimensions or the number of non-transparent pixels in the image so that I know how many pixels it'll take to draw. I save that as a forced 6-digit number so that it sorts correctly in the list when there's numbers of different lengths. All right, cool. That's done, and I don't need to worry about that anymore. And also, just while we're here, let me find... I'm looking on my second monitor right now. Just to compare and contrast between the wplace version and the bplace version. So that's wplace and this is bplace. Wplace, bplace. All right,